Okay. So I will start by giving a brief overview of the features that we will support in this area. And all comes down to execution of UML behaviors. And in UML there are 4 different kinds of behaviors which we support and which can be executed. Activities, interactions, state machines, and opaque behaviors. And while you are executing or simulating these behaviors, the diagrams, UML diagrams, will be animated and to show certain information like next to execute, in activities, sequence, and state diagrams. That's basically indicating the next element that will execute. In activity diagrams, we will show the location and cardinality of tokens. As you know, activities in UML execute according to token flow semantics. So it's important to be able to see where the tokens are located. For state charts, we will show the active state. By default, it's shown by a green rectangle. And also we have the possibility to show which elements you have executed so far. That can be useful if you, for example, want to study the coverage of your behavior to see where you have been so far. And you can, of course, control the execution as a user. There are stepping commands. They work quite the way you would expect them to do. If you compare, for example, with a debugger, we support breakpoints in exactly the same way as they work for a debugger. There is a command called run to here, which is basically a quick way of running execution up to a certain point. So that's basically a convenience for putting a temporary breakpoint, pressing resume, and removing the breakpoint afterwards. Then, of course, we have the traditional debugger like commands suspend, resume, terminate, and so on. And then also, since typically many UML behaviors are event-driven, we have a view for injecting events into the model during execution, and I will show that shortly. And finally, one way of controlling the execution is to respond to runtime prompting. If a model is informal in some way, that it's not clear how it should execute, then the tool will pop up a dialog to ask the user what it should do. And so that is one way of controlling what the execution will be. Then when it comes to composite structure and topology diagrams, we have some special features to show how messages flow between components. So, for example, if you execute an interaction or an activity, you can study the impact from a communication point of view inside the topology diagram or composite structure diagram. And it's also possible to see the historic messages that have been sent in the past. So the first demo I will show you is about basic functionality of model execution. It covers the commands you can see here in red. I will switch to RSA, and I will use a simple activity model to demonstrate the basic capabilities. This activity describes the process a company may use for hiring a new employee. And if we want to execute this model, we can right-click in the background of the activity diagram and select Execute as Model. Then the tool will prompt us to switch to a perspective called the model execution perspective, and we will do that. This perspective is very much similar to the Eclipse debug perspective, but it's appropriate for showing the views that are useful when you do model execution. And basically it consists of the debug view up here in the top left corner. This is the traditional Eclipse debug view, which is customized to show artifacts from the running model. So for example, you can see here that we have an instance of the class called recruitment. So basically what happened when I launched this activity was that the containing classifier, which was called recruitment, was instantiated, and that instance got the number 1 or name 1. Then we see down here in the diagram that we get this next to execute decorator. So you can see that this means that the initial node is just about to execute at this point in time. And then we have the traditional variables breakpoint view up here, just like you're familiar with from Eclipse debugging. The most common command to use in order to proceed execution one step is to press this button called step event. Basically, it will move execution one step forward. If I press that, you can see that two things happen in the diagram. First, the next to execute marker is moved down to the action node, meaning that that is the node that will execute next. And you also see that there is this green circle indicating that now there is a token on the edge that goes from the initial node to the advertisement action. And basically, the UML action semantics specify that an action can execute when all its incoming edges has at least one token. So actually, it is because of this token that we get this next to execute decorator on the advertisement action. Now, when I press step event the next time, we will actually go into the advertisement action, because you can see with the icon to the left here that this is a call behavior action. So this action actually calls another activity, which describes how advertisement takes place. So when I press it, I step into it, very much like stepping into a method when you are debugging Java. And I will press the button twice to reach. We have executed this fork node. The semantics of fork node is that it splits the control flow. So now you can see we have one token on each of the outgoing edges from fork. At this point in time, any of the actions, internal advertisement and external advertisement, could execute, because both have a token. So which one we will execute is not defined by UML, but of course in practice we will always pick one. And in this case, the tool, we pick the first one, internal advertisement. So I will execute that one and also the next. And that brings us to the join node that will bring back the flows, synchronize them again into one single flow. And finally, when we reach this node and execute it, we return control back to the calling activity. And now, before I continue to execute the rest of this model, I will show you that we can restart at any point in time by right-clicking on the session and selecting the restart command.
Matthias, sorry to interrupt. There's a lot of background noise. Could everyone please press *6 to mute themselves? Sorry about that, Matthias. If you can continue.
Okay, no problem. So what happened when I did restart is that we reinitialized the application to the state it was when we just launched it. And we do that by actually removing the previous instance and creating a new one. So you can see that this number goes from 1 to 2. And also then the next to execute marker is now back on the initial node. I mentioned previously the run to here command, and that is very convenient if you have big behaviors and you don't want to step into every single detail. And for example, I can invoke it here on the merge node as a means to quickly run to this node without stepping into the advertisement subactivity. And if I restart again, I can show you to do the same thing by using a breakpoint. So we have this toggle breakpoint command. You can see the breakpoint appears with this small little blue ball. And just like you are used to from Java debugging, you have the breakpoints visible up in the breakpoint view. You can enable and disable them by clicking the checkbox. And now if we press the resume button, the application will run at full speed until the breakpoint is hit. There it is. Okay, so I will remove the breakpoint. And now we'll continue to execute the next of this activity. Now we can see when I press step event, actually we get this information that the event queue is empty. There are no more events to dispatch. That means that we have now reached a point where we need external input to the application in order for it to continue executing. And this job application accepts event node means that it will wait until the user sends a signal to it. And we can do that in many ways. One way is to right-click on the instance and invoke the select signal event command. That will bring up a dialog that will list all the signals that can be accepted by this classifier, the recruitment classifier. And in this case, there is only one signal called apply for job, which seems appropriate. So we will press the send button. And you can see what happened when I sent the event is that it appeared up here under the recruitment. So basically, every instance has an input queue of events that are waiting to be dispatched to it. So at this point in time, we have the apply for job event in the input queue of this recruitment instance. And when I press that event, it will actually consume the event. It will be removed from the debug view, and you can see the next to execute decorator appears down here in the diagram, meaning that I can continue to execute this activity now. So let me press the button twice more, and now we are about to execute what is called a decision node in UML. A decision node basically selects one of the outgoing activity edges to give the token to. And since this is a very informal model, we have not defined the conditions formally using UML guards. We have just typed a name on the decision node and names on the outgoing edges. So for an informal model like this one, we will get this runtime prompting when we execute the decision. Basically, this dialog asks us to select which of the outgoing edges should we execute. So when we click here in the dialog, we can see in the diagram which of the edges that will get the token. And we will pick the yes edge to go down to the interview activity, interview action. And if I press that event again, I will reach another question asking us if this interview was successful, and we think it was. So then we will reach the hire candidate action, and finally we are at the last node, and when we execute that one, we will actually remove the instance, because that's how UML specifies the execution of an activity final node, what it should mean. So basically, this support is something you can use very early during design. When you have just started to create your UML diagrams, you can start to execute them to get a feeling for how they will behave. And so, I mean, the goal is that you should not have to create a complete UML model with the formal conditions and code everywhere before it can be simulated. But on the other hand, on the opposite, it should be possible to do this very early. I mentioned also the support for to show where you have been in the execution, and you can turn that on in the preference page. There is a checkbox called Mark Executed Elements. You can see if I apply that option, we get small gray icons everywhere we have been in the activity. So this can be useful, for example, if you want to study the coverage, if you have run big activities or big behaviors. I'll turn it off again.
Will it log the steps of where I've been? Like, if I could output that to some textual form, I could use that to start my manual test scripts over in RQM. Yeah,
that is actually something that is on the planned feature list, but it will probably not be done for 8.0. But we have some ideas of recording the actions and to be able to execute this automatically and repeat execution as a way of regression testing.
Okay,
so yes, yeah. Okay, so any more questions on this basic functionality before I continue?
Yeah, quick question. the decision nodes, will they act as breakpoints during full speed execution, or what happens after that? Does it continue to execute at full speed once the decision's been put in?
Yeah. So what we can do is if we relaunch this again, we will actually execute the same activity again, and we can run it at full speed. And you can see now the first time it stops is when it wants the signal to be sent. So we will send the same signal again. Basically, it has stopped when it reached this condition where there are no more events to dispatch. But now when we have the event, we can resume again. And then when we reach the runtime prompting, we can, of course, make a decision, but we can also press cancel. And if we press cancel, we will actually suspend the execution at that point. So that is useful if you have a big activity and you want to run up to the first choice, and then you want to start maybe manual stepping from there. So now I can press the step event to continue manually, and I will get this question again. I can continue execution manually. Did it answer your question?
Sort of. If you choose a decision, will it continue at full speed, or will you have to press the resume button again?
Okay, yeah, but I can do it. Now I am on the successful interview. I press yes. And you can see it continues at full speed.
Okay, thanks.
Okay, then I will continue to show more slides. Go into the features that are specific for composite structure and topology diagrams. When you execute certain UML behaviors like interactions and activities, it's useful to study the communication between components in composite structure diagrams and units in topology diagrams. And we can show that by animating the messages using these pink text boxes that you can see. And also for activities, we can show the token flows that goes between partitions, activity partitions, because those token flows indicate that some communication must take place between the components that are represented by these partitions. And we show that by a green label. And then also it's possible for interaction messages to be shown historically, so we can use arrows overlaid on the topology diagram to see where execution had been so far, where communication has taken place. And finally, there is a possibility to start execution from the context of the composite structure or topology diagram. And that is useful if you, for example, are a user that mostly thinks in terms of topologies and you are maybe not so familiar with UML, but someone else has created a large amount of UML scenarios in the form of, for example, interactions. Then you can just right-click on the topology diagram and execute those interactions without really knowing so much about UML. So the next demo will show you exactly this. So I will use a model from the RSA tutorial, which I think some of you may be familiar with. It's basically a banking example. So it consists of 3 components: account coordination, account management, and credit management. And we can look in the composite structure diagram how these components interact with each other. You can see that the customer is interacting with the account coordination component, and that component internally uses the other 2 components for its needs. So then I had created several scenarios that describe different kinds of communication scenarios. For example, I have a sequence diagram that describes the communication between these components when a user the customer here asks for a new account in our bank. So you can see that several messages take place. And now, of course, I want to execute this interaction, and I do it exactly the same way as I did with the activity. Right-click and select Execute as Model. I will switch to the model execution perspective, and now I will also make plays for both diagrams at the same time, so you can see them both. So now, when I execute this interaction, it will actually step through it one step at a time. And at the same time, it will animate the message communication in the composite structure diagram. So you can see now that we have this pink little box at the customer side, meaning that at this point in time, the customer is just about to send the receive account request message to the account coordination component. And when I press step event, you can see that two things happen. To the left, we get a movement of this next to execute decorator. And in the composite structure diagram, I hope you saw that the pink box was actually moved across the connector. I don't know if that came through. Usually a bit of delay when you do these web presentations. But actually that is how it shows. So now I can step through this scenario and study in my composite structure diagram how messages flow back and forth. So this is basically a way to understand the communication impact of a scenario described in this case with a sequence diagram. And just like I showed you previously for activities, it's possible to use the run to here feature to run to a specific point. However, if I select a message line, there are 2 points of the message line that can execute, both the sending and the receiving side. So when I invoke the run to here command, I have to select whether I want to run to the sender or the receiver. And it's the same for breakpoints. You have to specify if you want to toggle the breakpoint for the sender or the receiver. Okay, so then I will switch to look at the topology diagram that actually shows the same kind of information, but now with slightly more detail. So I created a deployment model. This basically shows exactly what I showed you in the composite structure diagram, but here I can also see that the components, where they are hosted, on which node, and where the nodes are located. So it's slightly more information here. And like I mentioned before, it's possible to start execution by right-clicking in the topology diagram and doing execute as model. And then you get a dialog that asks you which behavior to execute. And basically this works by analyzing the content of the diagram to see which behaviors that are relevant for what is shown on the diagram. So in this case, we found 5 different UML behaviors, and I will execute the same sequence diagram that I showed you previously. Once again, I need to make room for both diagrams next to each other. And now when I execute, the same thing happens as before. We can see the message flow animated in the topology diagram. But for topology diagrams, there is an additional possibility to turn off the history of messages, and we can do that in the preferences. Here in model execution, animation, and topology animation, there is a checkbox called Show Arrows for historic interaction messages in topology diagrams. And when we apply that, we can see that we get a colored line showing that message number 1 was sent from the customer to the account coordination component. And when we continue execution, we get new lines as messages are sent. So basically, this allows you to get an overlaid diagram with information about how communication takes place. And when you have executed your whole scenario, you have the full history of in which order messages were sent back and forth. And one way of using this feature is to actually save it to an image file. So you can use the save as image file feature, and then you can, for example, make it an image that you include in your presentations when you want to discuss this scenario with your stakeholders that are interested in this scenario. And some things that you may detect when you do this kind of work is that some communication takes place between locations, and maybe you should rearrange your deployment a bit to avoid too much communication between locations that maybe have a small bandwidth in their connection. Okay, I think, then one more thing I can show you. And you can see that when I terminate the execution, this information stays, because this is not the information I mean, it's historic information, so it can remain as long as the session remains here in the debug view. But when if I remove my session, the information will be removed with it.
So I can only see one scenario at a time on the topology, marked up on the topology diagram?
Yes, in the beta, we will only support animation of one scenario at a time. However, for the GA release, we are planning to support executing multiple scenarios and overlaying the information in the same diagram. That is something that, that's something that the people who have discussed this feature will have asked for, and of course it's useful if you have like hundreds of scenarios and you want to study the combined impact of all these executions at a time.
Exactly.
So that's something that we plan to do. Okay, I will execute one more behavior that is not a sequence diagram but an activity, just to show you how that looks.
Is this execution capability new to version 8, or is it in 7.5 now?
No, this is new to version 8.
Okay, I was wondering if I missed something there. Okay, thanks.
No, the entire area of execution is something we've added now. Great. So now, in this case, we are executing. It's basically the same scenario as I showed you in the sequence diagram, but now I will describe it using an activity. And you can see the lifelines correspond to activity partitions here. And it's also containing more details, which I could not show in the sequence diagram. And basically, every time the execution goes across partitions, for example, from the customer to the account coordination, that implies some kind of communication, and we will show that communication in the topology diagram. So at this point in time, we are actually about to start execution here inside the customer partition, so nothing is shown at this time in the topology. But if I press the event once more, you can see that we have one token now on the edge that goes between these partitions. And because of that, we can see the account request animated in the topology diagram. And just like before, when I execute it, it will actually move across. And usually when you execute, when one token is consumed, there will be other tokens present in the activity model. And in this case, I have two tokens, one up here that is going between the partitions, and that's why it shows in the topology diagram. But the other token is internal to the account coordination component, which means that it's not shown in the diagram. And now I can continue execution just like I did with the previous activity, and in this case we ask for this customer's credit status, and if we should do a credit check or not, and let's do it. And you can see that when execution goes on, we will continue animation, just like before. Okay, so I think that is what I wanted to show you concerning composite structure and topology diagrams. Any questions on this?
Yes, this is Lara from support. Since this type of support is completely new to our teams, can you maybe say a couple of words about the architecture? Are you instantiated as separate JVM? Are you generating temporary code? A bit of how it works behind the scenes, with the optics of, what should we collect and look at when it doesn't work as expected?
Yes, that's a good question. If I terminate this, I can show you briefly how it works. Basically, we are generating Java code. We're translating the UML behavior into Java code and using a Java runtime library, which implements the UML semantics for the different kinds of behaviors. So by default, these Java projects are filtered out from the Project Explorer, but you can turn them on if you go to the Customize view. And in the filters, there is this UML2 model execution implementation project. So if you turn that on, I did not refresh because I didn't press the checkbox. So now you can see that for every UML project I have, and this one is called Basics, I get a Java project called Basics Execution. And this Java project contains the Java code that was generated. And generation takes place automatically in the background, so it's not something that the user notices in the normal case. And down here you can see what the Java code looks like. So for example, here is an example of how we translate the signal that we had in the first example. And in this case, you can see that we are using classes from the runtime library that I mentioned. So basically, all this works by generating Java code and executing Java code, and then when execution takes place, we are generating events which are translated into different kinds of animations in the diagrams. So do you need more details, or is that enough for now?
It's enough for now. I'm sure we'll need more in the future. Thank you.
Yeah, okay. Any other questions? Okay, then I go on to my third section, which is about event-driven models. Like I mentioned, it's very typical that you have behavior models in UML that are driven by events. So it's important to be able to send events in an efficient way. And experience in the past from previous tools has shown that customers typically create large amounts of events. In the examples I showed you, I just had one event. That's not a very typical example. It's more typical to have hundreds or thousands of events. And also, when you send the events, you need to provide actual arguments corresponding to the signal parameters. And that is also tedious to do every time you send or inject events. So you have a need to actually store predefined set of events, including actual arguments. So to fulfill all these requirements, we have created a view called the event view. And basically, it allows you to define your events and giving actual values for signal parameters. You can omit specifying an actual value by using the star or asterisk notation. That is actually a wildcard, and if you send an event that has a wildcard parameter, the tool will ask you at runtime to provide an actual value for that wildcard. That can be useful if you, for example, you know the value of most parameters, but some are needed to be determined at runtime. The event view you can of course populate it manually by browsing for signals and one by one, but it's convenient to be able to automatically populate it by analyzing the model. So we support automatic population both from the design model. I mean, if you select a class, you will get all events corresponding to all signals that can be received by that class. It can also be done at runtime. So if you have an instance in the debug view, you can right-click on it and say that I want to have all events that this instance can accept in my event view. That's usually a good way of getting started, and then you can manually modify the events in the event view. Since it's typical to have a large number of events, it's important that you can filter the content, and we support regular expression filters. And it's also possible to click the checkbox called Show Only Events Applicable for the selection. And that is a way to actually filter the content by clicking in the Project Explorer. So, for example, if you click on a class, you will only see the events that can be received by that class. You can share events with your colleagues by exporting them to the file system and then import them again. Otherwise, all events are persisted in your workspace. When you send events from the event view, you can do it, for example, by means of drag drop. So you can take an event from the event view and drop it on the instance that you want to send it to. And like I've already shown, the events appear in the debug view when they are sent to an instance. So now I will show you this. And for this purpose, I will use state machine model because we have not seen state machines in action yet. So I created a very simple class called password changer. It's with this very trivial implementation. Basically, it's waiting in a state idle until a change password signal is received. And this signal has 3 parameters. It has a user ID, identifying which user that wants to change his password. Then it has the old password and the new password. All these arguments are strings. And when that signal has been received, the application will go into this validating new password state. And inside that is a composite state, so it takes place, some actions inside it takes place to validate the password, checking that it's at least 8 characters long and that it contains a number. And finally, if all these conditions are true, we will change the password and go back to wait for another request. So just like for activities and interactions, I execute the state machine by right-clicking the diagram. I should, of course, mention that I can also execute them from the Project Explorer, but I prefer to do it from the diagrams, usually easier that way. So now we are about to execute the initial node here, as you can see. And when I do that, we can see that there are no more events at this point in time, and that we are waiting in the idle state, and that's why we mark it in this green color. So now, if I want to send the signal change password, I can, of course, do it like I did it before, using the send signal event. But that can be tedious if you have a large number of events. We use this event view that I talked about. First, I will show you how you can manually add events to the view by pressing the Create New Event button and browsing for signals. So, for example, here I have my change password signal, and if I press OK, I will get it here, and I can decide to provide actual arguments. You can see as default we give the asterisk or wildcard for all arguments, and if we keep it that way, we will be prompted at runtime to provide actual values for this event. So I will keep it that way. And now, when I want to send this event to the model, I can right-click on it and select Send Event, and then it will be sent to the instance that is selected in the debug view. In this case, I just have one instance. So now we can see we get this prompt to specify actual values for our wildcards. So I will do that. And the syntax we use here is a simple string syntax. That's the same as you do in Java, for example. I will provide 3 strings. And you can see that now the event appears here in the debug view. I can use the variables view to change the parameters of events when they are in the event queue. So here you can see that, for example, I can change the old password string, and it will be changed in the event queue. So now if I press the step event button, this event will be consumed. It will be removed from the debug view, and you can see that execution goes down to the transition. That will take us to the validating new password state. And when we enter that, we see that it's activated, and we start executing inside it. And now, since this is an informal model, I will actually get runtime prompting to ask me, do we consider this password legal or not? Has it 8 characters? And it did not have it, I know it, so I will press no. And then we will go back to the invalid server state or exit point. So you could, of course, also create a more formal state machine model where you actually define the conditions that will actually look inside the received event and check if it has 8 characters. I mean, do it more like a programming style. That is also one way this support can be used. Okay, so I will send the event in another way this time. I will use drag and drop. I can take my event and drop it onto the instance, and the same thing happens. I get this event, this dialog. This time I provide some better passwords. And when I execute this time, I will answer yes to my questions. So we can reach the changing password state. And when the password changed, we'll go back to the idle state waiting for another request. So this is basically a very simple state machine example. And let me just finally show you how you can populate the event view automatically. If you right-click on an instance, you'll find this populate event view command, and it will actually ask the instance which signals can you accept, and it will create one event for each signal. And it can also be done from the for example, for package level. If I press on the package level, I do populate event view. You can see that I get all events I had there. I have some duplicate events already added before. Okay, so I think that was everything I wanted to show you today. Any questions on this last part?
Just one question. What languages can you interpret for the guard conditions?
Yes.
For formal models?
Yeah, for formal models, we use the upcoming UAL support, a UML action language. I don't know if there will be a demo of that in another session this week, but basically UAL is a subset of Java. You can think of it as for most parts it looks very much like Java. So in RSA 8.0 we will have a view called code view, which originally was part of RSA RT only, but now it will be part of the RSA also. Unfortunately, this view did not make it into the beta, so for the beta you will have to edit the language using the not so nice property editor in RSA. I don't know if you have ever edited guard conditions using the property editor, but it's not like user-friendly when it comes to typing code. But that it can be done that way at the moment. But in the GA release, you can use a code view, which basically allows you to click on any element in a diagram, and then the code view will show you the UAL code, and you can use name completion and all that stuff that you're used to from other Eclipse code editors.